Okay, let's look at question 2. Okay, so yes, it says a light string is suspended from a ceiling X. Okay, an object of mass 8 kilogram, an object of mass 8 kilogram is tied to the string at O. So we first have a light suspended from the ceiling at ceiling X. Okay, and then an object of 8 kilogram is tied to the string at O. So it is tied there. So there is that thing there off. And then a horizontal force of 60 newtons is exerted at point O. Okay, it is exerted at point O, causing what? Causing the string OX to be in tension. The system is in equilibrium. Remember, equilibrium, very important. Equilibrium means all the forces are balanced. So meaning sum of all the forces in the X direction, it is equal to 0. Sum of all the forces in the Y direction, it is equal to 0. Okay. So let's now look at this part. Okay. All right. So 2.1, explain the term forces in equilibrium. Okay. In words, forces are in equilibrium when the net force acting at a point, then when the net force acting at a point is equal to 0. Okay. Remember, if the net force is equal to 0, therefore it means those that object is in equilibrium and the forces are in equilibrium. Okay, or you can say it means the forces are balanced and the object will remain stationary. Okay, yes, or it will move at a constant velocity. Okay, if there is motion thereof. All right, then 2.2 says draw a vector diagram showing all the forces acting at object O. Indicate the angle theta in the diagram. So many students struggle to draw this, but it's very easy. Let me show you. What I want you to do first, it is to draw this one. Okay, there again, you know it is in tension, so you're going to say this is your tension. And then I want you to draw your gravitational FG here. Remember this this object here will experience FG. Again, this object will experience what? FG here. FG. So that FG will act here. Still, it is the same here, by the way. That FG. It's going to be experienced here. This is what we refer to as FG. Let me say this is tension. And then you can now connect the dots. Okay, I feel like it's too much. Okay. And then now what can you see? I'm done with the tension. I'm done with the FG. I'm now left with what? The 60 newtons. So I just complete this part to be 60 newtons. And can you see this is 90 degrees now? This is 60 newtons. So when I draw it, I can say FG. Normally I start with FG. Okay. And then just label this is FG, and then the 60 kilonewtons, here it is, not kilonewtons, sorry, just newtons, and then my tension at that angle like that. Okay, and then this is my tension, and remember my tension is just doing is creating an angle of 30 degrees with this one, so an angle of theta with this one. Okay, yes, guys, so it's just that. Okay, I hope everyone is doing good. Then this is my 90 degrees here. Okay, so this is what we refer to as a closed vector diagram. So I have drawn my closed vector diagram like that. Let me just take it here. Okay, and make sure that I copy and then paste it here because we're gonna use it. All right, and then remember this angle here. Okay, the direction is very important. And then this is my angle theta. Now let me take this question up here. Oh, okay, it's on another page. So now that we've drawn our diagram, remember you can get FG. FG, remember, is the same as what? MG. Good. So 2.3.1 says 2.3.1, calculate the magnitude of the tension in the string OX. The magnitude of the tension in the string OX. So how can I calculate the magnitude of the tension? So remember, I can say, okay, I can find FG. Remember, FG is the same as MG. So FG is equal to MG. And then my mass, it is 8 kilogram multiplied by 9,8. And then this will give me something like what? Like that. Actually, you know what? I'll do this calculation at the same once off. Now, the tension, it is my hypotenuse. Okay, can you see if I'm having a right triangle here? A, B, C. Pythagoras says C squared it is equal to A squared plus B squared. So I can say if I want my tension for 2.3.1, I can say T squared it is equal to FG squared plus my, I can say this is FA, okay? Let's just name this F, okay? Or force applied, okay? And plus FA squared, okay? And then my T squared is going to be equal to, what is FG? Remember, FG is the same as mg. So it's going to be mass multiplied by 9,8 all squared plus 60 squared. And then T is going to be just square root of everything there. Okay, Kappa, let me just say T squared, it is equal to 9,746, 9,746, 56. And then when you square both sides, okay, you get that T it is equal to 98.72 newtons. Okay, yes. And then let's move on to 2.3.2. Okay, let me just take this. I think I'm gonna do this diagram here. I think I copied it last time. Okay, now remember, I now know that my gravitational distance is 8 multiplied by 9,8. This is how much weighs my calculator. Okay, just quickly, can I do this quickly? 8 multiplied by 9,8. It is now 3978.4. Okay. 38.4. This is my FG. And then my tension I now know to be 98.72 newtons. By the way, this is newtons. And I still have theta here. Okay. So now the question is now, calculate angle theta. That string X, the string OX makes with the vertical. So that it makes with the vertical, this one. So the angle that it makes with the vertical. Okay. Yes. So what should we do? It's easy. You can say now, okay, I'm having my triangle. I can say sine. Okay, you can use sine, you can use tan, you can use cos, whatever that you feel like using. Okay, so you can say sine theta, it is equal to opposite. Okay, opposite, it is my FA here, divided by hypotenuse. My hypotenuse is tension. And then you can substitute that sine of theta, it is equal to FA, it is 60, tension, it is 98.72. And then theta will be arcsine, okay? Okay, on your calculator, this shift. And then 60 divided by 98.72. And then you get that your theta is equal to something like 37.43 degrees. Or someone might say, and I like to use tan theta. It is equal to opposite, which is FA, divided by adjacent, which is FG. And then tan theta, this is O. Tan theta is equal to 60 divided by 78.4, where now theta is going to be arctan of 60 divided by 78.4, and then your answer should be the same. Degrees. Don't forget the degrees. Okay. And then now the last question says 2.4, without doing a calculation, write down the magnitude of the resultant force at point A. Okay, the magnitude of the resultant force at point A. Now we don't even need to discuss and do any calculations. Why? Because we know that at this point, the resultant force F net or Fr, or the resultant force, it is equal to 0 newtons. Okay? Fr, it is equal to, or F net, still the same thing. It is equal to 0 newtons. Why? Why is it equal to 0 newtons? Because it is at stationary. You're going to say Fr, resultant force, okay, resultant force, it is equal to how much? 0 degrees. So not 0 degrees, 0 newtons, or just 0. Why? Because an object, this, you don't need to reason, your answer needs to be here. I'm just telling you, why is that? Because the object, okay, because the forces are at equilibrium. Okay, so yes, because now the forces are at equilibrium. You just need to see that, nothing more. Okay.